talk about just the last few things in the first chapter. Let's see if that worked. I don't know why nothing's working on this end. What are you seeing? Are you seeing just me, or are you seeing my overhead projector yet? Just a black screen. Okay, let's try to turn that on. No luck. Let's see here. Try this again. Really? Give me a break. Okay, I'm going to turn this off, and it may hang up on you, and then I'll call you back. Okay, now let's see if I can make it work here. No, it didn't help any more than last time. That's not really helpful. And let's turn that on. Still no help. Okay. In my other class, we were just holding things up to the camera at the back of the room. It was so ridiculous. Let's see what else I can do here to fix this. Well, sometimes this thing helps. Let's try to push some buttons on this thing. Camera, source, nothing. Source isn't. Choices. Well, that's not really helpful. And well, I've got a projector that's on now, even though the screens aren't down. That's progress. Something like that, anyway. Let's see if I can actually make it show something. Not likely, since it's not done anything so far. Inputs. My computer's still not working. Still don't know what that's all about. This whole room is stupid. Good night. Okay, the computer showed me something. Is that, it's got a cursor. Is Windows gonna start or is it just gonna choke? Hey, Windows looks like it's starting finally. So in about 30 minutes, Windows will be ready to go. It's been my experience with Windows throughout my life anyway. Let's see, does that show up on the screen there? Hey, I got a computer screen. Can you see my computer screen? Are you seeing my computer screen over there? Okay. That's success. Let's see if we can change it to something else now. Let's see if we've got another image. No, maybe so. No. Still fail on the document camera. Well, I guess we'll have to work from the computer today since that's all we've got. Yeah, it's because I switched over to my document camera, which apparently is just not connected to the system for some reason or another. I don't know why, but we'll go back to computer here, and we'll use the computer. We can find examples of everything we need to for the computer. Okay, so today we're going to finish up chapter 1. We didn't get quite all the way through it last time, but the rest of the stuff that we're doing in chapter 1 is not all that hard. I'm not going to be talking much about anything. I really wanted to emphasize some of the points at the very beginning about how to get in the right mindset to be an engineering student. Now we're just going to kind of give you some examples of the tools and the methods used, and then we will move on to chapter 2. So, I'm going to try the document camera one more time. See if I can get it to come up on the screen. Still. That was almost there. There was something there. It's not working now, though. Oh well. We lose. That's all right. So last time we covered things like, we need to be healthy, we need to manage money, we need to get along with people, manage time and everything else. All very important skills to learn, and skills that you can learn in high school just by being responsible and maybe a little bit more serious than your classmates around you, because most high school students are not necessarily that way. But they get on through chapter 1. They get into a section on study skills, and it's very important to have good study skills. I talked a lot about that when I talked about scheduling and managing time and having a good place to study. It's important. A lot of my daughter, for example, loves to study on the couch and just kind of relax. But she had discovered that she was taking like 3 or 4 times as long to do her homework. And then she liked to listen to some music or have a TV show playing while she was doing her homework. She was discovering that she was getting distracted very easily. It is well known and studied, it's been studied and shown that most students study best sitting up at a desk in a chair that is comfortable but not too comfortable, that sits up straight and without any distractions, including music or cell phones or anything else. And that tends to be the best way for just about everybody to study. There is not any true evidence that shows that there is even an appreciable number or appreciable percent of people that are different than that. Even though many students think they are, because they enjoy studying more and doing it another way or whatever else. Whether or not you enjoy it, the most effective way to study is at a desk where you can spread some things out, where you've got a big stack of paper to work with and some pencils and pens or whatever, and room for your books, your computer, whatever else you need, and free from distractions, free from other people, free from sounds or anything else going on. So I highly recommend you get used to doing that in high school. Even if you don't have a lot of homework to do, spend some time looking for scholarships every day and do it as if you were doing homework, and schedule the time and work hard at it, and fill out the forms and do the essays and everything else that you need to do to get some scholarships. And that's a good way to study to practice studying. And another thing that they really emphasize here are preparing for class and being a good student in class. Now, a lot of people think that taking notes is really, really important. And so they'll take notes and take notes and take notes and take notes. And for some people that really works. For me, it never did, because I just never went back and looked at my notes very often. I was too busy trying to get homework done. And some people have been doing studies on how to take notes, and there are different methods for that. One of the ones that's kind of interesting these days is to draw pictures and to do diagrams while you're taking notes. And I think that actually is a really good idea for most people, to minimize the number of words on a page and maximize the number of images that your mind connects to what you're learning. That can be very useful. But frankly, the most useful thing that I have ever found when it comes to going to class and being engaged in learning in class is to ask questions. Ask a question, write your question down in your notes, and then take notes, on the discussion that follows your question and any thoughts that you have as that discussion is going on. That way, your mind is opening and you're engaged, you're involved in what's going on, and you're much more likely to remember things, you're much more likely to get things out of it that are important, and the teacher is much more likely to be less boring. So, because let's admit it, most teachers are just plain boring. Even I get boring a lot, and I even notice it myself. It's just too easy to just talk about things. So, those kinds of things, of course, all very important, and that's great. Exams are something that really cause trouble for a lot of students. They cause a lot of anxiety for a lot of students. And I hope that you have teachers that don't subscribe to the theory that, an exam is the most important thing in a class, because it's not, and it needs to not be that way, because it's not the way the real world works, unfortunately. Fortunately, the real world doesn't work that way, but unfortunately, so many teachers think it does work that way. That there's some kind of time in your life where you're going to have to sit down with a bunch of things memorized and write it all down on a piece of paper or something. It doesn't work that way. More important in the real world is knowing how to find things, knowing where your resources are, knowing how to solve problems. So, but the real problem is that you are going to face exams, and that's going to be tough. It is extremely important to not fall into the habit of cramming for exams. If you don't know it by the day before the exam, you're probably not going to know it during the exam, no matter what you do. And especially if it's a high-stakes, high-stress exam. The most important thing you can do is to do your homework every day. And if your teachers aren't assigning homework, and unfortunately that happens a lot in college as well as high school, teachers are kind of getting lazy with homework because they don't want to grade it. And so they're just not assigning it. They're saying, here's some homework, but you don't know, you don't have to turn it in, or it's just going to be graded for completion or whatever else. Make sure that you're doing that homework and getting some feedback on that homework. If they're not going to grade that homework, go in and ask questions about that homework. If your teacher doesn't assign homework, assign yourself some homework. Do some examples from the book. Look in the homework sections for the book. Go online to a website like Khan Academy, KHAN academy.org. They have great things that you can learn right in their systems, and if you sign into their thing, they'll keep track of what you're doing and how well you're doing at it. But challenge yourself if your teachers aren't going to challenge you to work on different problems and to push the limits of your abilities. And that will, more than anything, prepare you for any kind of exam that you'll ever have to do. If your teacher is going to require you to have things memorized, memorize them the first day they tell you that, not the last day before the exam. Because if you memorize them the first day, every subsequent day, you'll have a chance to solidify those things in your memory as you use them in your homework, or as you hear them again in lecture or whatever else. So you have an opportunity as a student to be a good student, or just to be like everyone else. Because that's what most students are not great students in college and in high school. So do everything that you can to develop your studying skills, your homework skills, your classroom skills, and your testing skills, and that will do you loads and loads of good. One of the things that they show here is something called the spiral of learning in the book. It's on page 12, but in your book I don't believe it's there because you don't have the first chapter. But let's take a look at this. I think that I can find it online. Are you seeing my computer? I believe that I found it last year. Spiral of learning. The spiral of learning is essentially just kind of it's kind of an interesting graphic. I don't want to use Yahoo. Why do I keep using Yahoo? I hate Yahoo. I want to search Google. Besides, Yahoo just uses Google anyway. Oh, here we go, spiral of learning. Images for the spiral of learning. They have a lot of different versions of this on Google, it looks like. Let's see if we can find one specific to engineering. Spiral of learning engineering. Here's a good one. I like this one. So, can you see that fairly well? Okay. So this is a spiral of learning for engineering design, and it's specific to some kind of project they're doing, but the idea is still the same. Here you have this robotics module for engineering design that they're doing, and they've got this first spiral where they're learning fundamental things. They're learning DC motors, circuits, and electronics, and DC motors, circuits, electronics. And then they have a next spiral where they go to advanced circuits and advanced electronics and electronic drives, which are a specific type of DC motor. And then they're going to start applying this stuff in a bigger way. In the book, the one that they show is a little more general. It's not so specific to a specific project. It's a little more general. Let's see if we can find one that's kind of like that. This one might be kind of like that. No. That one's kind of like it, but for a different thing. But anyway, all these kind of spirals are meant to show you that you go around in this cycle every year of your schooling. But every year of your schooling, you come back to physics and you do another physics, but now it's a little more advanced. Or you come back to mechanical engineering, but it's a little more advanced mechanical engineering. So your first year, you're going to do all these things that are pretty much the same things you're going to be doing the rest of your career, as an engineering student. And you're going to start off as a freshman with some, you're going to have some general classes like literature and history and stuff like that will kind of be mixed into the education process. But after a while, it's essentially just going to be a spiral, this continuing cycle of engineering, math, physics, chemistry, maybe some biology, depending on what kind of school, what kind of engineer you want to be. But it'll be engineering, math, and science. Engineering, math, and science. You're going to be going over and over again through engineering, math, and science. And each year it'll be more and more focused on specific kinds of engineering, specific kinds of math, specific kinds of science, and then more complex engineering, more complex math, more complex science. And it's important to realize that because when you're in your first year, you're going to be learning something about mechanical engineering, and you're going to have a question. It's guaranteed you're going to have a question. Well, what if I want to apply this to this situation, which is a more complex situation? Your teacher's going to say, don't worry about that right now. We don't have time for that. We can only do the simple stuff right now. And that is part of the cycle. It's part of the structure of the engineering education model. So your first year will be very fundamental, pretty basic, but it will still be very challenging. Make no mistake that it will be very challenging. But the great thing is, even though it's challenging, and it may be frustrating because it's so challenging, you can take a little bit of comfort in the fact that you're going to be able to learn it again the next year. It's not the last time you're going to see it. So that after 4 or 5 years of engineering, you will become an expert in every one of these subjects, mathematics, engineering, and sciences. And because of the repetition that you get and the building upon the last year's model. So that is an important thing to also realize about your engineering education. And that is pretty much all we have to do. On page 13, they show a picture of a schedule for a student. Let's just take a look at one that we can find here on Google really quick. Maybe we can find a good one to show you. It's important to use some kind of a schedule, and I had one of these when I went my second time to school. It looked not unlike this. Let's take a look at it here. I generally had Sundays blank. I wanted to have one day a week that was open with nothing from school on it. And since I am a church-going person and a religious person, I chose that day to be Sunday. Sunday I would spend going to church, doing family things with my family, and just taking a complete break from school. And I would recommend that because you need a break. And you need a break pretty regularly. Usually about once a week you're going to need a break. So I would pick a day. And probably it's going to have to be either Saturday or Sunday because you're going to likely be in classes Monday through Friday. But I would recommend that. Now, some people would take off every night after 7 o'clock or something like that. I would not recommend that. That's not a good idea to have time off every day. What that creates most of the time in college is alcoholics. And I'm not kidding. That's not even a joke. Either alcoholics or kids that are addicted to dope. Addicted to some kind of marijuana or something. Because things that are going on at night at colleges usually are not the best things in the world. They're usually the parties and the drinking and the drugs and the illicit activities that happen around college, and it's just unfortunate that they do. But if you get sucked into that world, you will fail as an engineer. It is a guarantee, okay? Because you have no time for that kind of activity as an engineer. People who are doing, comparative English literature, they have all the time in the world for that kind of crap. It doesn't even affect them in class because everybody else in class has got the same thing going on. But if you want to keep up with some of the smartest kids you'll ever meet, and be expected to have your mind very sharp and very awake all the time, you cannot be out drinking at all during the week. And it does not say that you can't go have some fun on the weekends. I still wouldn't recommend drinking or doing any kind of drugs because all those things kill brain cells, and they're just kind of stupid. But if you want to have a day off a week, I would pick a day, but I would not do the thing that some of my peers and some people that I knew did, which is to take every night off. And all of them regretted it. Later in life, all of them said, I could have done so much better, I wouldn't have dropped out or whatever else if I just stopped, going to clubs every night or going out to bars every night. So it's something that you want to stay away from early on and create a habit of staying away from, because it will impede your learning. But notice that there's not just classes in here. This guy's got his classes in pink so that they're obvious. He doesn't want to miss any of his classes. But he's got a bunch of other stuff. For example, he's got a leadership speaker or something here. I don't know what this is. But there will be people speaking at the college you go to. There will be events that will be interesting and useful. Maybe in your engineering department, most likely you'll have an engineer that will visit the department every week from somewhere else to give a talk about what's going on in engineering. You should go to those. In most engineering departments, it's required to go to them. But even if it's not required, you should go to them, and you should meet these engineers, and you should talk to them, and you should listen to what they've got to say. And you should get used to hearing engineers talk about engineering. It's not only informative, but it's a good experience for becoming an engineer. And then as you talk to these people, you should get their card, and you should keep their business card with you. You should have a collection of business cards by the time you get done. So that when you're starting to think about where you want to go after you're done with your education, or if you want to go to another university to go to graduate school, you've got a list of people that you have met and shaken hands with. And then you can send them an email or call them up and say, hey, you probably don't remember me, but I listened to your talk on such and such, and I thought it was great information. I thought it was a really great project, and I'm interested in coming to your university. And they'll listen up to you, and they'll say, hey, why don't you apply, send me your information, and I'll see what we can do to fit you in and get you a fellowship. Now, if you're not familiar with what a fellowship is essentially a scholarship for graduate students that's worth approximately $50,000 a year. And they give out hundreds of them to graduate students in engineering. Hundreds. You will not find an engineering graduate student without one, in fact. Most engineering graduate students will have one. But to have the good ones is the ideal thing. You'd love to have a research fellowship where you can just go to classes and go to the lab and do nothing else, and they will pay for your schooling, and they'll give you a $20,000 check every year for your living expenses. That is ideal. And I know it's ideal because I had it. Okay? So it's great. You're essentially getting paid to go to school. You don't have to do anything else. You go to school, you work in the lab, and you're good to go. So you want to have connections with engineers and scientists that come to speak at the college. And every once in a while, somebody's going to come to speak at the college in some other department. And maybe you just want to go meet them, and that's fine, or listen to what they say. But you should write those things on your schedule, and you should do as many of those things as you can. You're going to have other things to do. You're going to have learning teams. This might be like a study group. And I would form as many study groups as you possibly can and join every study group you can. It will help you to get your homework done faster. It'll help you get feedback on your work. And you will meet some smart people that will be important to know as you're getting through your engineering education and your career. You will make friends for life in these things. And you will all graduate together, and it will be useful. That is probably the most important thing that I have to say today. Join a study group or several study groups and use them as often as you possibly can to get your homework done, to study for exams, and for social hour. You never know. You might meet a great person at a study group that's your friend for life, or you end up dating or whatever else, or marrying or whatever else. I ended up marrying somebody that I helped with math. So you never know what's going to come from those. But the best thing that will come from them for sure is you'll get a lot of help with your homework, and you'll get you'll be preparing for exams as you join this. So create a schedule like this and schedule things every week. On that one day off that you have, schedule everything. Just spend a 30 minutes scheduling things. or maybe your first day that you don't take off or whatever. Schedule everything and get everything ready to go. So that's everything for chapter 1 that I want to talk about. You have the homework problems that I've assigned. Make sure you get those completed and turn those in to me, email them to me as soon as you can. Chapter 2 is now where we want to be. And the first 4 sections of chapter 2 are essentially talking about what is an engineer. And I've kind of covered that in a lot of different ways, talking about going to school in engineering. Engineers are essentially problem solvers. Engineers are designers of things that solve problems or that fill needs. And in some ways, engineers are also builders of those things. But I don't want to necessarily go into it much more than that. We're going to see a lot more about that as we move along. I do want to talk about some of the people that engineers work with, and that list can get really long. Let's see if we can find a good list to put up here. Do engineers work with? Let's ask Yahoo this question. And of course I hate Yahoo. So let's copy that and put it into Google. Okay. So we've got a few different things to go with here. Engineer Girl. I've never seen this website. Let's see what this one's about. Wow, that's bright. Okay. Do engineers work with people a lot? I am interested in engineering, but I do not want to work with customers one-on-one as in customer service retail. Okay, so what do you think? What would your answer be so far as what you know about engineering? Yeah, that's a pretty good actually assessment of this question or answer to this question. Engineers do have opportunities to do a wide variety of things, and yes, there are engineers that spend 24/7 in their office, lab / environment, hunched over a computer or some electronic circuit. Frankly, I think that's the worst kind of engineering job ever. I would hate that. Some people love that, though. I've known several people that if they could just spend all their time just staring at a computer in a dark cave somewhere, they would be happy. You know, every once in a while somebody come by with some saltine crackers and stuff them in their mouth and pour some water in their ear or something. They would be happy for life, you know. And there are engineers like that. But for the most part, engineers are pretty social creatures in my experience. Engineers tend to be pretty smart, pretty nerdy kind of sometimes, but that actually does not prevent them from being social. It actually, especially as they grow into that, because it's an awkward thing when you're young, but as you grow older, it turns out that having a keen intellect is a great conversation piece, right? You can talk about a lot of things when you learn very quickly and you learn things very well. And so it turns out to be a great thing as you get older and you're an engineer. And so these kind of quirky little nerdy kids growing up in junior high school and high school turn out to be kind of the rock stars of the adult world. And so it's kind of fun. But anyway, you're right though. There is this broad kind of variety of jobs that you can do, and on one end of it you can be by yourself. But for the most part, I think it's a pretty social job. On this website, it says here, Dear Jill, engineering spans a huge spectrum of possible career options. Some of them work directly with people and others do not. Some work individually in small groups to develop software, hardware, devices, structures. Others work with people to develop prosthetics for people with walking disabilities, robots that can help people, the elderly in the home, or firefighters in the field, or architects develop intelligent buildings. So she gave an answer very similar to yours, and that's good. I think that's a good answer. I'm actually going to go somewhere else for this answer. Here's one right here. What do civil engineers do? Okay, what do civil engineers do? Let's watch a video. Let's get some sound from this video. How come I have no sound? Probably because my computer is on mute. Okay, let's fix that. Can you hear that at all? You know what? I can fix it here. Hold on a second.
It's in every road you drive.
Is that better sound? Okay.
In the clean water you drink. It's where you live, work, and play. It really is all around you. Civil engineers help improve the lives of millions of people every day. We're going to meet 3 civil engineers and look at some of the real ways that they're helping communities right now. America's waterway system is home to an entire ecosystem. The animals that live in the water depend on us to keep their communities clean. This is James Wannabe. James is working to create a healthy habitat and ecosystem in Washington, D.C.'s Potomac River. He's a resident engineer for the Blue Plains Tunnel, part of the D.C. Clean Rivers Project. This tunnel project is using a massive drill that's almost 30 feet high and over 400 feet long.
This is my office. We're here for DC Water, working on the Clean Rivers Project. This project is intended to eliminate sewer overflows into DC waterways, which also going to go down to Chesapeake Bay. Cleaning up the rivers. Right now we're working on a deep tunnel, Blue Plains Tunnel. And this is going to capture stormwater underground and allow that to be treated later after the main. The tunnel boring machinery used in here is an amazing piece of equipment. It's fantastic. It's 26-foot diameter, and it bores horizontally underground like a drill, and it holds back all of the earth pressures and hydrostatic forces that are below ground at that depth. It also allows us to install precast rings made out of concrete precast segments, and have a ring formed of pipe that will be there permanently after we're finished digging the tunnel. Civil engineering is a fantastic profession. It really deals with engineering all around us. There's infrastructure on the surface, things that people see and use every day, like roadways, bridges, things of that nature. And there's also a tremendous amount of civil engineering below the surface that no one ever sees.
So I hope that you can kind of see that this guy, this is what I see as a typical engineer. I've known literally hundreds, maybe even thousands of engineers in my life because I grew up around engineers and I went to school with engineers and my family are engineers. This is a typical engineer. And I hope that you can recognize that, yeah, I could see him as a nerdy kid in junior high school, right? Can you see that? You can totally see the development of this totally nerdy little kid into this adult. But this adult is well-spoken. He's obviously not shy. He's obviously very confident with himself. He is obviously intelligent. You can tell just by the way he speaks that he's intelligent. And he's obviously very used to speaking to people and working with people. And this is what you will see in a lot of engineering. And it comes from not just their choice to be this way, but also the development of their mind and the development of their social skills as they go through engineering. Students in engineering have to be social to survive, because the work is hard, and they have to ask questions, and they have to be willing to ask questions, and they have to be willing to go to a professor who's got a Nobel Prize in something because they're so smart, and confront this guy and say, I got some questions, I need some help. So, I mean, this develops naturally for engineers who are actually, who are trying to succeed. And when they do, this is what you get out. My two older brothers are both engineers, and my youngest brother is an engineer, and they all fit this mold. I could paste their faces right in here, and they could talk about their work, and they would be just the same. And there are so many people, so many engineers that are like this. They are this very, and no, they don't all look the same. Sometimes you'll have an engineer with a ponytail, and sometimes with a big beard or something. They come in all varieties, but they all tend to be very well spoken, very intelligent, very easygoing with speaking with people. So this is certainly not uncommon. Let's watch the rest of this. Let's hear about this.
Here, in my view, that's one of the best parts of civil engineering is working on the underground side. It's so much fun. I never imagined I'd be able to work on something this cool, but I always had an interest in making projects. I love being part of it. It's a great mission. We're every day excited to do this, and can't wait to see the end result come. My name's James, and I'm a civil engineer.
Hurricanes can destroy entire communities that then take years to rebuild. Maggie Jakes is a civil engineer who went to Haiti to help restore clean drinking water after the hurricane. Maggie was forever changed through her experiences in Haiti, helping a desperate community and touching lives.
So my junior year in college, my professor did a presentation on his trip to Haiti and what he found when he was there. And their biggest problem was drinking water. They didn't have clean water to drink, and thousands of people are dying each year because of this. So he was trying to get civil engineering students from Merrimack to travel there. 2011, we traveled to Haiti for the first time. We went to a town called Marmont, and this is where severe cholera outbreaks hit every year. There's a big clinic there. We saw all the cholera tents still set up from their recent outbreak. The system was damaged by the 2010 earthquake, and it was broken in a few places, but the water was relatively clean. So we made food repairs to that, and they were just so grateful that we were there. Because we were there, we gave them hope. In the United States, we're really lucky to have access to clean water, and that's thanks to years of hardworking engineers. My experiences in Haiti and my later years of college really opened my eyes to how many possibilities there really are for civil engineers to help. My name is Maggie Jakes, and I'm a civil engineer.
Baseball. The crack in the bat, the roar of the crowd. The amazing ballparks that are home to our national pastime. Meet Aaron White, the civil engineer in charge of designing the hurricane-proof retractable roof at the Marlins Park in Florida.
This is the first roof in the world that's designed for a Category 5 hurricane. It weighs roughly 7,800 tons. It's steel, and actually designed to be positioned in a slightly open position for the hurricane, so that wind into the space and then back out. Obviously, anytime there's a threat of a rainstorm during a game, you have a problem with rain delay. Miami rains here pretty much every day for the summer, so they have the ability to close the roof very quickly. So there's a guarantee that the game's going to happen. That's extremely efficient. The mechanization is very efficient. It's designed so it only costs about $10 in electricity. So early on in the design, we tried to establish what the minimum height of the roof length is. We scoured the internet and found some equations put out by NASA. Flight of the batted ball. And through those equations, we can actually calculate the flight of the batted ball, all the ball behind the bat, goes straight up in the air, straight horizontally, nice trajectory on the line. So we actually created those shapes early on and put them over the length to make sure that the shape of the roof up interact with the
engineers have cool jobs. They're creative and innovative people. They make an impact and change lives, making our world a better place. That's the bottom line. If you want an amazing...
Okay, so that is one here. Let's look at, there's some weird things on YouTube. Let's look at some ones by a guy that I know does day in the life of an engineer. Let's see. Let's go to, we did civil, let's do let's do, what kind of engineering were you interested in again? Yeah, let's look at this one. I've not seen this one before. I've seen this guy before.
Structure and the deployment mechanisms that deliver power to the world. So every time we deploy the solar arrays, which we've done quite a few times, so that it's a critical requirement. I get so excited because you're just seeing something that somewhere in the back of your mind you get this idea and all of a sudden it's there. You know, it's not just this is a team of presence, but there's nothing like seeing your hard work do what it's used. Benefits of working in NASA are, at the end of the day, when you go home, you're one of the few people in the world that built our data. That's exciting to me. Some other things that you just, you know what, I get to play. Every day I wake up, I get to go to work, I get to play. I get to do what I wanted to do. It's great fun, and I get to play. You know what? They would have to do a job. They make a lot of money, but I'm doing pretty well. Going to Mars is different. 2/3 of all the missions have gone to the surface of Mars. We know the risk of going to different places. I mean, we go 6 minutes of terror. From the time we hit the atmosphere to we hit the ground is 6 minutes. We're going 12,000 miles an hour to zero in that 6 minutes. Just doing that in any vehicle is very difficult. Now, imagine doing that remotely with no interaction from human beings from Earth on a canned sequence. It's not a huge leap of faith to say that's a difficult thing to do. And then you start to say, well, what percentage will we put on it? For most of us, we do all the testing that we can to prove it. And then you say, well, here's the best that we got. What is it about Mars that excites me? This is our sister planet, or something that is like our sister planet. And I think the biggest question that everybody's out there has, did Mars support life? Because if that's true, that life is like ours, that's amazing. Now, the bigger thing is it like ours, which is amazing. So, both ways, it's like, wow, we really like it. Because we know that there is a water ice trap. We believe there is water trap. And everywhere we find water, everywhere we find that is just follow the water trap. And if we can find water, for the most part, is traveling dollars. There's a rock hammer around. And it's able to look through the weather line of the rock, the time of the rock, to see what environment it's living in. So it's looking for places where water may have existed and looking for signs of that water within the rock. Being able to do it is actually great because not only are you standing on the shoulders of great people, but you are starting to build a foundation for great people that will come. And that opportunity. Most important classes for high school students that we like to enter a field of physics, this is what I wanted to do since I was 7 years old. So I mean, this is it.
I love what he said, that he gets to get up every day and go to work and play, right? This is something that so many engineers love about their jobs, because it's something that's enjoyable, it's challenging, and it's just dang fun. And even teaching it is fun. That's one of the reasons I like teaching so much, is because I get to come every day and do this stuff and learn about this stuff and explore this stuff and experiment with it, and then I get to come back and do it again. So anyway, the rest of this chapter, this section in 2.5, chapter 2, just goes on and talks about other types of engineering and how they're related to each other. And of course, there's lots of things, lots of different engineering fields. And the homework for tonight kind of touches on some of those things. The homework is at the end of this chapter. It's numbers, let's see, what is it? Looks like we have 3, 7, and 8. So number 3 in my book says identify 5 companies you might want to work for. Explain why you'd like to work for them. Is that what it is in yours? And then number 7 is for each of the following industries, list all the engineering disciplines they employ. Is that number 7 for you? And then number 8 is describe a world that lacks one of the following engineering disciplines. Okay, so those are the 3 problems for tonight. We're talking, a total of probably 2 pages of writing at most. Nothing really hard to learn, nothing really hard to do, really, but learn as much as you can and do a little research if you can on the computer, maybe see what other people are saying about those subjects, and then write that up. And we're done for today. No problem. You have a good one.